All right, are you ready to dive into some seriously cool image segmentation? This paper, Think Before You Segment, high-quality reasoning segmentation with GPT chain of thoughts, it's a wild ride, and we're going to try to break it all down for you.
It's pretty revolutionary stuff, really. I think the best way to think about it is this paper introduces a new framework. It's called ThinkFirst, and it uses the reasoning power of GPT-4 to really amp up image segmentation quality.
Okay, so you're saying this is like next level stuff.
Definitely next level. You know how Sam, the segment anything model, kind of blew everyone away?
Oh, yeah.
For sure. Think of it like Sam, but it actually thinks before it goes and segments the image.
Whoa, okay, so why should our listeners care about this?
Because it's getting crazy good results, especially with images that are usually really hard to segment, like pictures with camouflaged objects or blurry boundaries, things that even we have trouble seeing.
So this could be a huge deal for fields like robotics and medical imaging, anything where image segmentation is crucial.
Exactly. And it all comes down to how ThinkFirst uses this chain of thought prompting approach. It lets GPT-4 analyze the image, really get into the details, and create this super detailed summary before it even sends the information over to a segmentation model like Lisa.
Okay, so walk me through that. How does that actually work?
Well, it's like GPT-4 is asking itself questions about the image, answering them, building on that knowledge, kind of like a detective, piecing clues together.
Oh, that's a cool way to think about it.
And get this, they tested it on some seriously hard segmentation problems, like those camouflage images from that COD10K dataset, and even underwater images from MVK.
Oh, wow, those are both notoriously difficult.
Right, and ThinkFirst just crushed it, blew the other methods out of the water. Like, we're talking big improvements in those typical segmentation metrics, GIOU and CIOU.
Yeah.
But it's not just about the numbers. When you actually look at the segmentations, you can see ThinkFirst is picking out those hidden objects, is getting those tricky boundaries in a way that just wasn't possible before.
I love that they even used it to play Where's Waldo?
Yeah, that's a classic, and it often stumps even humans, but ThinkFirst nailed it.
So this shows the potential for this kind of reasoning-based segmentation in applications where you absolutely need accurate, robust results, even in tough environments.
Exactly, and it's just the beginning.
Okay, so those are the key takeaways. That's perfect for our short form edit. Now let's get into the nitty-gritty, shall we? The researchers were going after those tough segmentation problems where traditional methods just fail. So tell us about this ThinkFirst framework. How does it work?
Well, it all starts with GPT-4. They give it these carefully crafted prompts designed to make it analyze the image in a step-by-step logical way. This is that chain of thought prompting I was talking about earlier.
Okay, so GPT-4 is looking at the image and almost like asking itself questions, right? And then using those answers to build a deeper understanding.
You got it. And that understanding gets turned into a super detailed image summary, which then guides the segmentation model. In this case, they use Lisa. It's like giving the segmentation model all the intel it needs to do its job perfectly.
Instead of just throwing the image at the model and hoping for the best, you're giving it a roadmap.
Precisely. And those tests, remember on the COD10K and MVK datasets, ThinkFirst showed significantly better results, especially when compared to the usual methods. And it's not just about the numbers. Again, when you look at the actual segmentations, the difference is really obvious. ThinkFirst can pick out those hidden objects. It can draw those tricky boundaries in a way that just wasn't possible before.
This is where it gets super interesting to me. You can interact with ThinkFirst using text queries. You can even use image scribbles. It's like you're having a conversation with the segmentation model, guiding it to get the exact results you need.
Yeah, it's a whole new level of control and interactivity in image segmentation. And yeah, the Where's Waldo example, they used ThinkFirst to actually play that game. They gave it the image, asked it to find Waldo, and it did.
Wow. A task that even humans struggle with.
Right.
So we've got this framework, it's more accurate, it's more robust than traditional methods, and it's more interactive and user-friendly. Pretty impressive stuff.
Yeah, it really is. It's like we're seeing a huge shift in image segmentation, where reasoning and understanding are becoming just as important as those low-level visual features.
So let's dig into this reasoning aspect a little more. What's actually happening here that allows ThinkFirst to achieve this level of understanding?
Right, so the paper dives into the actual architecture of ThinkFirst, and like we said, there are three main parts: a vision encoder, a mask decoder, and of course the star of the show, the vision language model. That's where GPT-4 comes in. Now, they're using a pre-trained vision encoder and mask decoder, similar to what's in SAM, but the magic really happens in that vision language model.
So GPT-4 is like the brains of the operation.
Exactly. It's the one doing all the thinking and reasoning, and to make it work for this, reasoning segmentation, they fine-tune GPT-4 using a technique called LoRa.
LoRa.
Yeah. LoRa lets them really efficiently adapt GPT-4 without having to retrain the entire model, which would be, impossible computationally.
That makes sense. That's a smart move.
Yeah. So they've got GPT-4, they fine-tuned it with LoRa, but how do they actually get GPT-4 to think about the image in a way that's useful for segmentation?
Yeah, how do they do that?
Prompts. They use a mix of what they call environment prompts and task-specific prompts. The environment prompt basically sets the stage. It tells GPT-4, hey, you're an agent for language-based image segmentation. Really describe this image, focus on the stuff that's going to help a segmentation model.
So it's like setting the ground rules, telling GPT-4 what its role is in the process.
Exactly. And then the task-specific prompt gives more context. For example, it might say, describe the image and find any camouflage objects.
Okay, so that's how they get GPT-4 to focus on those tricky things that other segmentation models would miss.
Precisely. So imagine you have an image like a fish camouflaged against a coral reef. Most models would have a hard time separating the fish from the background.
Right, that makes sense.
But with ThinkFirst, you feed that image to GPT-4 along with those carefully crafted prompts. And what happens next is really cool.
What happens?
Well, GPT-4 starts analyzing the image. It starts asking those questions like, what's the overall scene? What objects are there? And how does the camouflaged object relate to what's around it?
Exactly. It's like GPT-4 is dissecting the image. It's pointing out those crucial features, the relationships that the segmentation model needs to know to correctly identify the fish. It's giving the segmentation model a big advantage.
That's a great way to put it. So then, based on that chain of thoughts, GPT-4 creates a concise summary of the image, which, along with the user's query, is then sent to the segmentation model. Yeah, so in this case, the summary might be something like, there's a camouflaged fish that's blended in with the coral reef. Segment the fish.
Right, so armed with that detailed understanding, the segmentation model has a much better chance of correctly identifying and segmenting the fish. It's like it has X-ray vision now.
I like that analogy. It's not just about identifying objects, it's about understanding their attributes and how they fit into the bigger picture.
So that level of understanding opens up all these possibilities for things that need precise, robust segmentation. Medical imaging, self-driving cars, robotics, anything where you need to accurately pinpoint objects in messy environments.
Exactly. To sum it all up, ThinkFirst is really changing the game for image segmentation. By combining GPT-4's reasoning skills with the power of models like SAM, it's able to handle even those super challenging images and produce highly accurate segmentations.
And we can't forget about that interactivity. Users can communicate with ThinkFirst through text or those image scribbles, giving them so much control over the whole segmentation process.
Right. And it's making me wonder what other areas of AI could benefit from this kind of deep reasoning. What if we applied this chain of thought approach to things beyond just segmentation?
Ooh, that's an interesting thought. We'll have to ponder that one.
Yeah.
So what else did the researchers discover in their experiments? What kind of hard numbers did they get?
They did a deep dive into ThinkFirst's performance, comparing it to those other reasoning segmentation models like Lisa. And no surprise here, ThinkFirst did better consistently, especially in those tricky scenarios we talked about.
I bet they used those standard metrics, GIU and CIOU, right?
Oh, absolutely. And ThinkFirst has significant improvements on both. So that means it's producing segmentations that are more accurate and precise than what's out there now.
That's solid evidence.
Yeah.
Did they do anything else to, back up their approach?
They did these really interesting ablation studies. They're experiments to see how much each part of the model contributes. They basically wanted to isolate the impact of the chain of thought reasoning to see how much it matters.
So removing the thinking part and seeing what happens.
Yeah. And taking out the chain of thought reasoning had a big impact. ThinkFirst's performance dropped quite a bit. That tells us that this reasoning process is the secret ingredient behind those amazing results.
Makes perfect sense. Take away the brain, and the model loses its ability to really understand the image.
Right. Without that deep reasoning, it has to rely on those more superficial features and patterns, which we know can cause problems, especially with more complex images.
So the chain of thought reasoning is the key. But did they test it with, tougher queries? Not just identifying an object by its class, but something more complex?
Absolutely. They gave ThinkFirst some challenging queries like, which object can move like an animal? Or, two people want to sit together. Which object should they sit on? These kinds of queries need a deeper understanding of the scene and the relationships between those objects.
So they're testing whether ThinkFirst understands what the user actually means, not just the literal words.
Exactly. And ThinkFirst nailed it. It segmented the correct objects. It shows that it can handle nuance and complexity that we haven't seen before in image segmentation.
Really groundbreaking stuff. Looks like ThinkFirst could be used in so many areas. Robotics, self-driving cars, medical imaging, who knows what else.
Absolutely. This framework is opening up a whole new world of possibilities for using AI to understand and work with visual information.
Well, we've covered a lot of ground. Why don't we take a little break and come back to talk about some of the limitations of ThinkFirst and maybe what future research could focus on?
Sounds good. We'll be back in a jiffy with more insights from this incredible paper.
Okay, welcome back. Before the break, we were talking about how ThinkFirst is using this chain of thought reasoning to get those incredible results in image segmentation.
And how it's opening up all kinds of possibilities for all these different applications.
Right, but I'm curious about how ThinkFirst handles those user queries, the ones that are more subtle, the ones that go beyond just identifying objects by their name.
Yeah, those more nuanced queries. Like okay, let's say you've got an image of a living room. Sofa, armchair, coffee table, the works. And your query is, two people want to sit together. Which object should they sit on?
Okay, yeah, now that definitely needs more than just recognizing what the objects are. You need to understand what they're actually used for.
Exactly. So ThinkFirst takes that image, feeds it to GPT-4, along with all those prompts we talked about, those environment prompts, and the task-specific ones.
Okay, so GPT-4 is looking at the image and asking those questions like, what objects are here, what are they used for, and which ones can you actually sit on?
Yeah, exactly. And it's using that huge knowledge base it has to answer those questions. So it might say, sofas are usually for multiple people to sit together, armchairs, they're for one person, and of course, coffee tables, they're not for sitting.
So GPT-4 is using real-world knowledge to figure out what's going on in the scene and what each object is used for.
Precisely. And based on all that, it puts together a summary that tells the segmentation model what's important. So it might say, this living room has a sofa that's perfect for two people to sit together. Segment the sofa.
Ah, so the segmentation model now knows exactly what the user wants and why.
Right. It knows to focus on the sofa because it understands that's the object that fits what the user's asking for.
So we're not just recognizing objects anymore. We're understanding their purpose in the scene and how that relates to what the user needs.
Yeah, that's the power of ThinkFirst. It's connecting seeing with understanding. It's letting AI systems tackle things that need a much deeper understanding of the world.
I was looking through the paper, and they have a ton of examples of ThinkFirst handling these complicated queries. It really shows how far we've come in getting AI to reason about objects and scenes.
Yeah, it's pretty amazing. And it's not even just about those super clear queries. ThinkFirst can handle queries that are ambiguous or even incomplete.
Okay, what do you mean by that?
Say your query is something like, segment the thing that looks like a stick.
Oh yeah, that's pretty vague. Lots of things in an image could look like a stick.
Exactly. But ThinkFirst uses that chain of thought reasoning to figure out what you actually mean. It might ask itself, what kind of stick are we talking about? Is it something natural, like a tree branch, or something man-made, like a tool? What other clues are in the image that can help me figure out what the user means?
So it's using its knowledge and the context of the image to fill in the gap.
Exactly. And then it can create a more specific instruction for the segmentation model. Like it might say, okay, the user's probably talking about that tree branch over there. Segment the branch.
Wow, that's super cool. It's like ThinkFirst is actually part of the conversation, figuring out what the user wants and making sure it gets it right. It's not just following orders blindly.
Yeah, and that's a huge step towards building AI that's smarter and more adaptable, AI that can actually interact with the world in a meaningful way.
I totally agree. But let's switch gears a little bit and talk about how ThinkFirst actually works under the hood. We've talked about GPT-4 and those prompts, but what about the training process? What kind of data do they use?
Good question. One of the coolest things about ThinkFirst is that it uses a zero-shot approach.
Zero shot? Hold on, does that mean they didn't train it at all?
Not exactly. ThinkFirst uses those pre-trained models we were talking about, like GPT-4 and Lisa. But here's the thing, they didn't train ThinkFirst specifically on, a bunch of image segmentation tasks. They just used the knowledge that those pre-trained models already had.
Wait, so they got all these great results without any specific training on segmentation? How is that even possible?
That's the magic of their prompts. They designed them to guide GPT-4 to use what it already knows to solve image segmentation problems. Remember those environment prompts?
The ones that tell GPT-4 to act like it's an agent for language-based image segmentation.
Yes. Those prompts, plus the task-specific ones, give GPT-4 everything it needs to figure out what it's supposed to do and create those detailed image descriptions.
So they're basically repurposing GPT-4 for image segmentation using clever prompts. That's amazing. But what about the data sets they used to test ThinkFirst? Did they use anything especially challenging?
They tested it on a whole bunch of data sets, including some that are known to be really hard for image segmentation models. One of the main ones they used was KOD-10K.
KOD-10K, what's that?
It stands for Camouflaged Object Detection. It's all about images where objects are blended into their surroundings, so they're super hard to detect and segment.
So it's like the ultimate camouflage challenge.
Right. And ThinkFirst did remarkably well on this dataset, much better than those baseline models that don't use that chain of thought reasoning.
So it really shines in those tough spots where other models fail. What other data sets did they use?
They also used the MVK dataset, which is Marine Video Kit.
So underwater images. Those are notoriously difficult because of the colors and the blurry edges?
Exactly. This dataset is a challenge for a completely different reason. Underwater images are tricky because the colors are often distorted and the boundaries between things are blurry. It makes it really hard to segment things accurately.
But I'm guessing ThinkFirst handled it just fine.
Yep, you guessed it. It consistently performed much better than the other models, showing just how robust and adaptable it is. And they even threw in some images of modern architecture, which often have those super complex shapes and lots of detail.
Wow, so they really put ThinkFirst through its paces.
They did, and it got impressive results every time, showing that it can handle all kinds of images and segmentation tasks.
It's really amazing what they've been able to do with this chain of thought reasoning and those well-designed prompts.
I know, right? It shows the power of combining language, understanding, and visual processing in this really new way.
And they didn't just rely on those numbers to evaluate ThinkFirst, they also did those qualitative evaluations, visually comparing its results with those of the other models.
Oh yeah, and when you look at those side-by-side comparisons, it's clear that ThinkFirst is creating much more accurate and precise segmentations, especially in those difficult cases we've been talking about.
So it's a winner in every way.
Absolutely. It's a huge step forward for image segmentation. And it's exciting to think about how this could be used in other areas of AI. If chain of thought reasoning can work this well for image segmentation, imagine what it could do for other tasks that need deep understanding and reasoning.
Yeah, it's like we're opening up a whole new world of possibilities. But we've been talking for a while. How about we take a quick break and then come back and talk about some of the limitations of ThinkFirst and what directions future research might take?
Sounds good. We'll be right back with more insights from this groundbreaking paper.
All right, we're back, ready to wrap up our look at ThinkFirst. This paper has been a wild ride, all this cutting-edge AI and incredible results.
Yeah, for sure. We've seen how ThinkFirst combines the reasoning power of GPT-4 with these pre-trained models like Lisa, and it's safe to say it's a total game changer for image segmentation.
But like anything new, there are always, limitations, things we can improve, places we can push it further. So let's talk about some of those challenges and what the next steps might be.
One thing that the researchers pointed out is that GPT-4, as amazing as it is, can still make mistakes when it's reasoning. It's a language model, right, at its core, and sometimes it can misinterpret information or make errors, especially with those really complex or ambiguous situations we were talking about.
Yeah, that makes sense. It's relying on its understanding of language and the world, but that knowledge isn't perfect. There are going to be gaps, inconsistencies, things like that.
Exactly. And those reasoning errors, they can affect the segmentation results. If GPT-4 misses something important in the image or misunderstands what the user's asking for, it can lead to the segmentation model focusing on the wrong things.
So we still need some level of human oversight, at least for now, to make sure everything is accurate, especially in areas where you absolutely can't have errors.
Right. Like in medical imaging or self-driving cars, there's no room for mistakes. However, the researchers do think that GPT-4's reasoning will get better as language models become even more advanced. So the future is looking pretty bright.
It's amazing to think how quickly these language models are getting better. What other limitations did the researchers mention?
Well, another one is the computational cost of using GPT-4. It's a huge model, and running it takes a lot of processing power.
So it might not be practical for applications that have limited resources or that need answers right away, in real time.
Yeah, that's a good point. But the good news is there's tons of research happening right now on making these large language models more efficient. So as technology gets better, we'll probably see the cost come down quite a bit.
It's like the early days of computers. They used to be giant, expensive, and slow. But over time, they got smaller, faster, and cheaper. It seems like large language models are on a similar path.
Yeah, I think that's a fair comparison. And even with these limitations, ThinkFirst is a big deal. It's a huge step forward for image segmentation. And it opens up so many possibilities for future research.
Definitely. The paper talks about some of those potential directions. One thing they highlight is the need for better ways to evaluate these reasoning segmentation models.
Right. We've talked about those metrics, like GIUU and CIOU, but they might not be enough to really capture what's going on with these tasks that involve complex reasoning and understanding.
Yeah, it's not just about how accurately a model can outline an object, but whether it actually understands what's going on in the scene and why the segmentation matters. We need better ways to measure that deeper level of understanding.
Exactly. They talk about exploring new evaluation metrics that can really assess whether the model gets what the user wants and can create segmentations that are actually relevant.
That makes a lot of sense. What else did they mention in terms of future research?
Another thing they talked about is making these reasoning segmentation models more explainable. Right now, ThinkFirst is kind of a black box. We can see that it works, but we don't always know why it makes the choices it does.
It's like a magic trick. You see the outcome, but you want to know how it happened.
Yeah, exactly. And that lack of transparency can make people hesitant to use it, especially in fields where trust and accountability are super important.
Yeah, it's like the difference between just seeing the answer and actually understanding how you got there. The more we understand how these models work, the more confident we'll be in using them.
Absolutely. And lastly, they touched on the exciting possibility of taking this chain of thought approach and applying it to other vision language tasks, like object detection, image captioning, video understanding. There's so much potential.
Imagine a world where object detection models don't just tell you what objects are there, but also explain why they think so.
Right, or video understanding models that can sum up the main events and relationships in a video, just like a human would tell a story.
So many possibilities. It seems like ThinkFirst could be just the beginning of a whole new era of AI, where these systems can really understand and interact with the world.
Yeah, it's a really exciting time to be working in AI. Who knows what incredible innovations will come out of all this research?
Well, that wraps up our deep dive into ThinkFirst. We hope you found it insightful and maybe even a little bit mind-blowing.
We hope it's made you curious about the potential of AI to change how we see and understand the world.
Thanks for joining us, and we'll see you next time on The Deep Dive.